Thank you very much to you all, and thank you, Carlo, for inviting me to this event. I'm really, really happy to be here and to share my knowledge or my experiences with marine Mediterranean biodiversity. I'm not so happy because I just learned that I'm living in one of the most polluted cities in Europe. So it's making my mind to move away. So sorry for you that came to my institute to make the meeting because you got some polluted air in your lungs, whatever. Well, this is, I'm here to present some just few information about Mediterranean marine biodiversity. As you know, this is a huge subject. I am a marine ecologist. Mainly, I'm working in marine conservation. I'm looking for a sustainable use of marine resources, and this is my main specialty. I'm not a taxonomist, so probably if there is some of you that really well know taxonomy and everything, I'm not going to be able to answer all your questions. But what my activities seek are that the biodiversity, the functioning of the systems, of the marine ecosystems, they keep working well in a healthy way, and they're providing the services that they are furnishing to us for all our civilizations. Okay, I'm working, as you say, at the Institute of Marine Science in Barcelona, and I'm the coordinator of this research group, which belongs to different institutions in Barcelona, and some of the people working with me in Barcelona, and in collaboration also in some other countries in France, for instance, or in Italy. So many of the things that I'm going to tell you today are coming from the work that I've been doing with them, and from other researchers working on the subject, because as I told you, this is a huge, huge subject. So the key message that you have to keep in mind when you will come back to your home is that as you hear, I guess that you know more about the Mediterranean now than me, because I saw the list of the presentations that you have been attending these days, and it is really amazing the quantity of information that you got. But from this presentation, the key message, if you have to have one back home, is that the Mediterranean is a hot spot also for marine biodiversity. Probably we just heard that it's a hot spot for climate change, for air pollution, everything, but also is a hot spot for marine biodiversity. And all those problems that we saw, they make sense to conserve marine biodiversity, as you will see. So why we say that it's a hot spot of marine biodiversity? The estimates that we have, they say that we have more than 17,000 species. Mainly of those are macrospecies. We are not talking about microbes or viruses or things like this that we cannot count. These are things that we can see with our eyes. So we have algae, seagrasses, sea urchins, echinoderms, polychaetes, fishes, even marine mammals, seabirds, anthozoan, corals, ascidians, bryozoans, a long list of species. I provide you some of the numbers of those species just to have an idea on the numbers of the species. For instance, for foraminifera, we have more than 1,600 species found in different areas of the Mediterranean. Macrophyta, which it means the algae, the red algae, the green algae, and also the seagrasses, we have more than 800. Only for Rhodophyta, the red algae, we have more than 400 species. It's a huge, huge richness of biodiversity. Mollusca, we have more than 2,000 species of gastropods, snails, opistobranchs, many of those species. Crustaceans, we have more than 2,000 species from crabs in the plankton, living in the middle of the water, living on the rocks, living beneath the rocks, living down deep in the water. The shrimps that we always like to have in the paella are from crustaceans, and things like this. The fishes, we have more than 600 species of fishes that we also like to have in our dishes, and that they are providing also recreational beauty to see, because all of this, beyond the fact that they are providing us services, it's the result of the huge process of evolution that provides us this treasure, this heritage that we have to share with all other organisms and that we have to share with our generations in the future. And this is why we are working, to share this treasure for the future. So I told you the number, 17,000, more than 17,000 species in the Mediterranean. And we say also that this is a hotspot because it's about, from the estimates, because as you know, the estimates of biodiversity, it's a huge debate. I mean, there is a lot of work still to be done. But it's about 10% of all marine species that have been recorded up to now, more or less, because this changed from one day to another. But the Mediterranean has less than, it's about 0.1 ocean surface, which means that if we protect and we conserve the marine biodiversity that we have in the Mediterranean, beyond that this is our duty, or it is our responsibility to do this, we will be contributing in a large measure to the marine conservation in the all oceans. And one of the most important things also in the Mediterranean is that most of those 17,000 species, in fact, we can only find them in the Mediterranean, are what we call endemic species, that we can only find them. So if we lose them from the Mediterranean, we will be losing them from the rest of the oceans. So this is another reason to conserve the Mediterranean biodiversity. So why we think, or why are the reasons we've found so many species and such a richness on biodiversity in the Mediterranean? There are many, this is also an entire talk to discuss about this, and I'm just going to give you some key points or key information. The first thing is the historical geological history of the Mediterranean. As you know, probably in some of your talks these days, you saw that the Mediterranean deformation, it was open. Sometimes it was closed from the connection from the Atlantic. Then the water comes and fill again the Mediterranean. So this provides some new opportunities for colonization and for evolution and for speciation of the different of new species. We know also that there were movements that it was more open in geological back millions of years ago. It was more open. So all these processes, these geological processes, favor the existence or the evolution of the different, the coexistence of different species and the result of this huge biodiversity. Then there is also the geomorphology. This, as you already know, is a semi-enclosed sea. It's the largest semi-enclosed sea in the Earth, and it has only one open in the Strait of Gibraltar. And it's quite deep. It can have more than in the mean is 1,400 meters. And you have the rocky coast, you have the sandy coast, you have the platform, you have the deep seas. You have many structures that also provide some different habitats for the different species, and they can provide also this place for the development of many species. And the last thing that I wanted to raise is about the environmental gradients. As we saw in the previous presentation, the Mediterranean has these environmental gradients. It goes from west to east, and we have, for instance, as it was already mentioned, this is the productivity. So we go from this area, which is really productive, to the eastern part of the Mediterranean, which is not so productive, and this can provide different conditions for the different species that they can develop different strategies and find the places to develop in the different areas. So we have also this. I didn't put the map of the depth, but here these shallow areas in the Adriatic Sea, so this is more enclosed. So here we have the influence of the Atlantic water coming in from the Atlantic coming into the Mediterranean. So there is this trend that here the water is more saltier, and all these different conditions, all these environmental gradients that we find in the Mediterranean in a such short latitudinal gradient, it provides the good conditions for the development of biodiversity. I put here, I don't know if you see it, the references that if you want to check, if you want more information, I try to provide all the time the reference here if you want to have more information about this. So, as I told you, I'm working as a marine ecologist, and I'm working mainly in coastal areas. And within the coastal areas, because we have the sand beaches, what the tourists really like, I'm working mainly in rocky areas, in rocky coast. Why? Well, this is kind of my marketing, but I'm going to deliver anyway. Coastal areas, if we think in all this the marine biodiversity that I told you, it's mainly concentrated in coastal areas. And this can be easily understood, well, first, because it's the areas that are more studied, because it's more easy to access to the study, but also because this is the surface, and this is going deep in one of those rocky walls that we have here. This is the Medes Islands in the Catalan coast, but if we put ourselves a diving suit and scuba diving, and we go from the surface to deep about 40 or 50 meters, we cross, there are a lot of gradients also. We were talking about environmental gradients somehow in a horizontal way, and here I'm talking in the depth gradients. Here we have more light than here, so here we can have more algae than animals, but going down, what we have, these are gorgonians, and some rhodophyta that they live with really low light conditions. So in just few meters, in tens of meters, we have really different conditions for the species that they develop. So in an area like this, we have thousands of species that we can find in a really short space. So this is an example. I have many pictures, but since the time was short, I tried to provide some examples. So this we are here at 10 meters depth in Corsica, and this is a forest, a real forest of a seaweed, Thistosera balearica. It's called Thistosera balearica, and you don't see here, but these are algae like this size. And we think it's like we like to say that this is like the forest that we have in the terrestrial ecosystems. Although here all this is smaller, in the Mediterranean this is also a characteristic. It's a feature of the Mediterranean that everything is smaller. Probably because the sources of energy, the sources of nutrients are much lower. But this is a feature of the Mediterranean biodiversity. And within this forest we have these different species of fishes, like our birds in the terrestrial ecosystems. And I don't have the images, but you can imagine that within this algae, we have mollusks, crustaceans, snails, many of other species. And in fact, in that size, if you take a quadrat and you put there the quadrat in this forest, and you know enough taxonomy of different groups of species, as some of my colleagues do, you can find more than 200 species in just a piece of those forests. So it's a huge biodiversity reservoir in this kind of habitats. And I want just, this is the final slide from this introductory part. And I want to recall that the Mediterranean has marine mammals. So we associate usually marine mammals to dolphins and whales and things like this, that we have those in the Mediterranean. But sometimes the people get surprised to know that in the Mediterranean, still now, we have the monk seal, which was all over the Mediterranean, not so far away, not so long ago. In the 50s, still in the Spanish coast, we have the monk seals. And now they are gone, and we can only find them in Greece and in Turkey, and another population in Mauritania. But this is kind of a recall that we have a lot of things in the Mediterranean, and this photo from Turkey, it's from a monk seal that it was taken from, it was lost in the beach by a storm, and the people in Turkey, they have a center of recovery of those animals, and I had the opportunity to swim with this monk seal. It was a really huge experience in my life. I mean, knowing that those kind of animals exist now in the Mediterranean, that we usually see in the National Geographic documentaries from other parts of the world, and it's a pity that we cannot be able to experience, all of us, that to know that those species are still there, and they can be, that we get rid of them in many, many areas of the Mediterranean. And hopefully, it's going to be really hard, but hopefully someday we will see it progressing or colonizing again the Mediterranean. And the last message from this is that the biodiversity is really underestimated. I told you at the beginning, it's 17,000 species, but there are many in the deep sea. We have really little information from the microbes. There is a huge biodiversity to be discovered still. So what are the drivers of those changes? So we have the biodiversity, and what is making change to those changes? Drivers of change, sorry, in a negative way, because I'm not talking about evolution and all these conditions, but the sequence of the human disturbances that we produce in the marine ecosystems. So we started by fishing, then we polluted the waters, then we destroyed the habitats, then we favored the introduction of invasive species, and then the last one is the climate change, that it's covering all the things. So we came from pristine situations to alter ecosystems where the things are not working as they used to work. Okay. So as I'm not going to go into detail of this is the Anthropocene, but this is a map. It's an effort to map the cumulative impacts of human activities in the oceans. And the most striking image that it came from this map is that nowhere in the oceans, even far away from the coast, are safe from our activities. So this is a really powerful image that I wanted also to share with you. And the Mediterranean, of course, is a threatened sea because we have been developing our civilizations for thousands of years in this sea, and these are from Roman mosaics. I don't know where they were taken, but this is a grouper, a huge grouper that was eating. I don't know if it was true or not, but it was eating a person that was swimming by there. So what is the main changes that they produce, these human activities? This is from fishing, but we can say it for all the disturbances. We go from really complex ecosystems to systems that are really simplified. So we don't have big animals, we don't have almost nothing in the bottom, so we lost many things, and many of the things of the function of these ecosystems. And here I'm going to show you some impacts coming mainly from my background or my experience in research, But I think that it was good to share with you some details on how we do research. So one of my main subject species is the red coral. It's a coral. Well, of course, it's a coral. It's an anthozoan living in the Mediterranean. It's not like the corals that you see in the coral reef because it has no symbionts. So it lives, as you see in the photo, it lives in dim light habitats with no more light, and it has the polyps, but I don't know. So it has been used by jewelry since millennia. We have in the archaeological sites, we can see the pieces of the red coral that was used in the burial ceremonies and many things, and so it has been fished by thousands of years. And here, for instance, in this image, you see this baby with a piece of red coral, and it was fished for many years till the early 90s by this kind of engine. It was a bar with a lot of nets attached to the bar, and then this was dragged through the bottom with the boats. At the beginning it was the rowing boats, but at the end now it was with engine power boats, and it was moving through the bottom, and it was catching pieces. Imagine the destruction of those kind of engines. So we have been studying the red coral, and we said the red coral. This is a cut of one of the trunks of the red coral, and we could set up a method to age the colonies. So all of these lines is a growth rings like we have in the trees. So we can count them and we can measure them. So we measure that the growth rate in diameter, it was about 0.5 millimeters. Imagine this, nothing. It's a colony of 1 centimeter in diameter. It's more than 60 years old. So it's really slow growth rates. We are using also these photogrammetric methods that we put this kind of quadrats and making photos. So we have this red coral population, and so we make pictures, and we set those marks in the field to make permanent transects, what we say permanent transects, like that the people do in terrestrial ecosystems. And with those methods, we make several photos of the same scene, so we can make measurements on the colonies, and we can have, like the people do for the trees, the size of the trees, etc. So, and we can also calculate this from the same plot at different years, and we can measure the tiny growth also of the red coral in height, and it's about 1 millimeter per year. So this really slow growth rate. So it used to be in the Mediterranean colonies like this, that probably this colony has more than 300 years. It's more than 300 years old. And this is the kind of the colonies that we have now in most of the places. So it's really small colonies. So if we take all the information that we have, this is the depth range, and this is the height of the mean height of the colonies. And you see that going deeper, we have larger sizes because they have more not so impact by the fishing activities. And if we can compare the populations in red from marine protected areas from the populations outside marine protected areas, what we see is that inside, since there is no fishing, the sizes are larger. But if we take this information and we compare this, the percentage of larger colonies in different populations. So these are populations in marine protected areas, and these are populations in fished populations. So we set this level, this threshold, to know if the populations are in good status or bad. And we take all each line here, it's one population for which we had the information, and the conclusion is really sad that there are only 10% of the populations that we have information that they are in a good conservation status. And this is the case for the red coral. But if we look at the fishes, we have more or less, it's happening the same. This is the same species. This is the grouper. This is a grouper in the Mediterranean. This is exactly the same place, the same age of kids. But, and he found the fishes, the same species, but the size, it's not anymore the same. And it's not only the size of the fishes, it's the abundance of other species. In the 40s, in the Catalan coast, we can find some sharks. In the coast, rowing with the boats, we could find and fish some sharks. Now it's impossible. You cannot find them because they were overfished. So you can imagine the change in the ecosystems that can. The second example that I wanted to show you is the climate change effects. This is an image of the warming of the Mediterranean, and the Mediterranean is warming 2 to 3 times faster. The water, not only the air, the water is warming 2 to 3 times faster than the rest of the ocean. And of course, the warming, the color means the different warming rates. It's not the same in the eastern part, which is warming even much faster than that in the western part. But the message is the Mediterranean is warming and warming really fast. And one of the consequences of the warming that we saw is these mass mortality events, something that we never saw before. In the early 2000s, we saw this kind of events. This is the population of a gorgonian, the red gorgonian, which is not the red color, but it's a larger species. And this is what happened with the mass mortality. All these things that you see here in red, you see here there is the tiny piece of red. But the rest of this is only the skeleton. It's just the skeleton. It's not alive. It's the skeleton of the gorgonian. So it's like the fire forest that we have in the terrestrial ecosystems. This is what's happening beneath the surface. We have true fire forest beneath the surface. Another feature of those mass mortalities are the larger scale. They affected thousands of kilometers of the coast. This is what we saw in the mortality of 2003. This is only, I'm not going to go into detail, this is the percentage of the affected colonies in different areas. And another feature of those mortalities is the wider range of species affected. These are sponges, these are the gorgonians again, these are the red algae, more sponges, ascidians, mollusks, many different, up to more than 30 species from different phyla, up to 6 different phyla. This is a cladocora, this is a coral, this is like the bleaching in the coral reef, but this is not bleaching, this is necrosis. And we saw that there is a relationship. This, in red, there is the necrosis rate, so the rate of mortality that we saw in the population in different years. And in black, there is the temperature, and you see that there is this nice correlation between the temperature conditions and the necrosis. And another feature that is really sad is that these lines here, I don't know if you see it, but we use these permanent plots to monitor the populations. So this was in June 1999, and we came back in November, just a few months back, and it's exactly the same permanent plot, and you saw that these are the dead gorgonians, and you saw that it was a devastating event here. And if we translate this in biomass, so this is in June 99, and in November, we had a drop of more than 50% of biomass was lost in this event. And the worst part is that we have been monitoring those populations, and there is no signs of recovery for those because they are really long-lived species with a slow dynamics like the red coral that I showed you. And warming of the Mediterranean is also a driver for the arrival or for to speed up the colonization of alien species or introduced species. This is an example, this striking example of the rabbitfish At the Siganus, there are two species of Siganus species that they enter from the Red Sea by the Canal Suez, and they are colonizing the eastern part of the Mediterranean. And what happened is that we used to have this Cystisoera forest that I showed you at the beginning in those areas, at least in some areas. And with the arrival of these species, what happened is that we pass from those kind of landscapes to this kind of lunar landscapes where there's no Cystisoera, no cover of seaweeds. And they are colonizing by adults, but these are the juveniles of those species. And now what is happening is that this species is one of the main preys for the fishermen. They are catching them, so it's becoming a major fishing resource for them. But even like this, they cannot stop the destruction of the change or the alteration of the ecosystems in the eastern part. And the last part of my talk is about potential solutions. So, as you know, conservation biology is devoted to promote actions, research, activities to reverse this trend. We are in this situation, which is that we still have the system working more or less, although there are some pieces that are already missing, but we want to go from this bad condition to the pristine or to the good, healthy condition of the oceans, where everything is much richer and the systems are more complex and everything is much good for the ecosystems, but also for us. But at the end, because if we push in this direction, we will have a problem for ourselves. And so even if we are selfish, we have to look to move in that direction. Okay. And one of the major tools that we have in marine conservation is marine protected areas. And this is an area that is fished, so there is the net, and this is an area that is protected. And this illustration, what it shows is that in the marine protected areas, we have their biomass, and if we have, this is the biomass and the density of different indicators. This is a review of the effects of marine protected areas, but within the marine protected areas, there is a positive change in biomass of fishes, in biomass of different species that we work on, or in the density. So we have richer and healthier ecosystems in the marine protected areas. And this figure shows the evolution of the surface of marine protected areas across the oceans. Okay, and so the last years we have been, you know, even in the media there was these announcements that United States protected I don't know how many square kilometers in the Pacific. Then it was France, and then it was Chile. I don't know if you have followed this, but this shows this trend. The sad thing of this positive news is that the total percentage of the ocean surface covered by this is from the year 2015, so probably these figures are a little bit higher, but it has not a really significant change. But it's 3.5 surface of the oceans, or a little bit more, are protected now. But only 1.5% are real, what we say, marine protected area, what we say is no-take areas, where you cannot fish, or you have a limited activities within the areas. So in those areas that are no-take, there are some regulation for fishing, so they are not really effective as a tool. But you have to have this in mind. Really a small portion of the ocean is being protected, and even the part that is protected, the measures for protection are not so efficient or so effective. And what about the Mediterranean? Because in the Mediterranean we have all these yellow dots here are the different marine protected areas that we are deploying or implementing in the Mediterranean. And this figure is updated from the last year that we have a meeting in Tanger about the marine protected areas in the Mediterranean. And we have about 7% of the surface of the Mediterranean covered. But again, if we take out this big area, this Pelagos sanctuary, that it's only for marine mammals, we stay at 3.6% of the entire Mediterranean. So this is really low. And if we look at no-take zones, those areas that are really effective, we go even lower on those numbers. So this really, we have to make an effort to move forward on this. So you know that for the international conventions, there is this target, there is this target that 10% by 2020, so in 2 years. So we are making progress. We cannot say no, but we have still a lot of things to do. I know that you work as a secondary teacher. They are secondary teachers, and I think that there is also an opportunity for you and also for me that there is this. This is a project that I'm involved with Sea Watchers, but it's a citizen science initiative, and I think that this is really interesting for you because the Sea Watchers, I'm presenting the Sea Watchers, but there are other initiatives probably in your countries that you have this. And it's promote this dialogue between the scientists and the society. And because we need this to get this, to raise the awareness about the change, about the environmental problems that we have in the Mediterranean, in the sea, and make the change to propose things, and if the people knows what is happening, it's going to be much easier to implement effective measures. So we have this web page that you can check if you want, and I saw this, what is providing a global vision on what's going on in the Mediterranean about different issues, environmental issues, to improve the communication between scientists and the society, and an opportunity to share the knowledge, not only from the scientists, but also from the society, because some of the people working as a fisherman or that they work daily on the sea, they have information that we can share, and this is important for all of us. So this is more or less how it works. It's a typical workflow of this kind. And I wanted we have, in this platform, in the Sea Watchers platform, we have 12 projects working now. They have specific questions, and they are providing you specific methods how to work with this project. And I want to point out or underline the possibility for you to work in this project, which is Plastic Zero, which is our main problem now in the seas. And if you go and check in the project, you will find the materials, probably if you want to go to the sea to make some activities with your students to work in this. And if you find other things that you can do in the platform, it would be good. The final message. These CO2 emissions that we saw in the previous talk, and this how it has been raising. So this 2008, that it seemed that with the crisis we had a positive thing, that it was a decrease. This is global measures, not what happened in Spain, that it was really low. But these lines are the different scenarios that the scientists, probably some of them are working now here, are producing these different scenarios. So this is the worst scenario, and this is the safest scenario. And sometimes people say that the scientists are alarmist, that they just say things without, okay, it's important, but you know, we have to move forward, and we have to the development of our societies, and it's more important and things. But what happened now is that if you see, this is the real measurements, and probably this is not updated, but we are above of the worst scenario. Come on, let's do something. Because if we go in that direction, we will be in really bad position for the future. So no matter air pollution, marine biodiversity, everything, our society is going to collapse. And we don't want this for us, need for our future generations. Thank you.